So good morning again to everyone that has just joined us, and hello to anyone watching the replay. Welcome to another one of our online webinars. This time it's all about understanding surveying dampness in below ground structures. I'm your host, Andy Ferguson, and I'm pleased to welcome back my colleague, James Berry, Technical Manager at the PCA. We are about to start the main presentation. Just before we do go into start, for those that are joining us, if you do want to ask any questions over the course of the webinar, I'll just very quickly point you to the chat facility on the desktop that will be running down the right or the left-hand side. If you're on a mobile, you just need to pull up and you'll see the comment section there. Alternatively, if you want to email your question to me, it's just andy@property-care.org. That's andy@property-care.org. Equally, if you are watching the replay and you do have some questions, use my email address, ping it across to me, and I will endeavour to try and get your question answered. So, James, I can see we're pretty much bang on 9 o'clock. I suspect the many individuals listening to this webinar very much have inspected or even surveyed below ground structures at some point, or certainly maybe had to have considered designs for maybe converting basements and cellars. But I suppose, and this is the big question with regards to this webinar, whether it be that you're doing a property survey or you're inspecting for remedial repairs, when it comes to dampness in these particular spaces, James, what are our key considerations? I mean, what are the limitations and implications when expecting these spaces? And what should we be evaluating in these spaces? I know this is very much your bag when it comes to structural waterproofing, James, and I'm very much looking forward to hearing what you've got to say. Over to you, good sir.
Thank you very much, Andy. Well, if I answer your question straight away, then I defeat the point of the webinar, don't I? But morning, everyone. Having a look, there seems to be a good mixture of you. Some names I recognise, some that I don't. And, you know, it all seems that you're in different parts of the world as well. And some bragging about the sunshine as well. I can tell you it's definitely not sunny here. And my kids are distraught because they've just had their sports day cancelled. So it's definitely not sunny over in Huntingdonshire. But anyway, let's crack on. Good morning, all. And as Andy said, I'm James Berry. I'm part of the technical team at the Property Care Association. I think some of you know me. If you don't, hello. So today we are going to be looking at basements. We have done several things on basements before. We've covered several aspects in basements previously. So we've covered podium decks, 8102, building regs for basement conversions. We're not going to stray too far from that today, and we're going to be looking at surveying habitable below ground spaces essentially. Now, as far as I see it, you're going to find yourself in a basement for one of three reasons. One, that there's a defect there and you've been called to go and look at it. Two, that it's a pre-acquisition or a pre-purchase survey. Or three, that you're there because you're being asked to do a survey prior to it being converted into something a bit more special or habitable space. We're not going to look at that one today. That is probably a webinar in its own right, and it's kind of covered in a PCA code of practice as well. So I'm going to park that one. The intention for today is we're going to sort of look more at the surveying aspects of it. We're going to be looking more to sort of the surveyors. If you're an out-and-out waterproofing specialist, some of this is going to be sort of fundamental, the basic level. But bear with me because there's going to be some quirky stuff in there as well for you that I think will be of interest to you. So please do stick with it. But that's the angle we're going to be coming at. We are going to be covering it from a domestic structures point of view as well. Now, as far as I see it, if you're doing inspections of any property, at some point you're going to find yourself in a basement. Now, when it comes to dampness in a basement, there are additional considerations, and if you're not aware of them, if you're not sort of have at least a a small understanding of them, then there's the opportunity that they're going to catch you out, and no one wants that. So that's where we're going to be aiming today, is to sort of try and increase awareness of those. So at least you'll have a bit of a mind as to what it might be, what it might not be, and where to go when to go to get specialist help. So straight off the bat, do basements need to be dry? Well, in my opinion, no, they don't, as long as they are dry enough for its intended use. So to put that into a bit of context, now I'm going to use a statistic here, which is a tiny bit out of date. It's from a BRE paper from 2004. So it's, it is a little old, but it says that there are 550,000 basements in England. Of those, 3/4 predate 1919. So bear in mind, there has been a bit of a resurgence in popularity of basements recently, over sort of the last couple of decades, where we've seen sort of house prices increase, land values go up, and diminishing urban areas, or diminishing spaces in urban areas becoming more sought after, we're increasingly going down. So the 550,000 is probably a bit out now, but we're probably not far away. But the reality is there's still a substantial proportion of our basements are pre-1919. So what were they used for? Why did we have all these basements so long ago, and why did they sort of diminish in popularity? Well, you've got to start thinking about where we were at the time. Most were dampish and relatively poorly ventilated, but they were used for storage. They were used for storing food, water, coal, fuel, that sort of stuff, or even sort of drying laundry. But they didn't need to be dry spaces. They were sufficiently dry for what they were used for, and that was enough. And there's nothing wrong with that. If that's what you want a basement for, you can still use a basement for that. And if you're finding yourself in a structure that is like that, then actually that's relatively simple and relatively easy to survey. As long as it's ventilated enough, and as long as there is no risk to the structure, then that's fine. You may want to keep it like that for retaining the heritage value of the property. However, the reality is not everybody is going to want a basement like that, and that's probably not going to be acceptable when you're looking at habitable spaces. So damp isn't always tolerable, or the volume of water is where it becomes an issue. So what sort of damp, and we are going to go start from the basics and build up, what sort of damp can affect our basements? So let's start off with capillary rise of water, rising damp. Obviously normally associated with our above ground structures, but the reality is if you've got a retaining wall in a basement, the chances are it's going to be below the level of damp proof course. DPCs, are by good building practice always 150 mil above external ground height. So if you've got a structure that is below the level of damp proof course, then it can absolutely be affected by rising damp, because there's probably very little to protect it from capillary rise of water. Second of, we have rainwater. Now that seems a little left field, admittedly, but bear with me. It feels a bit more topical today, though. If you're anywhere near the southeast or East Midlands, it's a bit wet here. But if you can cast your mind back almost 2 years to the day, where we were inundated with images of London underwater, but most notably a lot of basements with a lot of water in them. One of the most notable ones was perhaps Brian May, who we sort of had a lot of headlines, lost a lot of memorabilia, musical memorabilia, because his basement was flooded. Now, having spoken to a great number of people that were out in the field at that time to sort of try and get a bit of a feel for what was going on, it was not, by all accounts, that waterproofing systems were failing. It was because we had unprecedented levels of unseasonal rainfall coming down, causing flash flooding, and we had systems that were overtopped. It was coming into light wells, and it was simple things like areas where there were dropped curbs. We were seeing flood water going over those and into basements that way. So the other thing to bear in mind as well is we're seeing climate change, and the reality is that our rainfall patterns are changing, and things like what we saw 2 years ago, and given today as well, where we're getting a lot of rain again, not to the same extent, but we are seeing, you know, different rain patterns now. So that is something that we've certainly got to bear in mind. Next off is sort of water created in that basement. So we've got two: escape of water, which is your plumbing defects, leaks, that sort of thing, so fairly self-explanatory, and of course condensation. Now, condensation is obviously liquid going from its vapor form to its liquid form, and we will see it quite a lot in basements, and basements make quite a handy area to hide our utilities, you know, our washing machines, our tumble dryers, things like that. So huge thing, or things that can contribute hugely to moisture loading in basements. So that is something we're going to concentrate on in a bit more detail a bit later on. But thirdly, and the one that is perhaps, or fourthly, I should say, sorry, the one that is going to affect basements and almost more unique to basements is lateral penetration. So where you've got higher ground level and there's a possibility of hydrostatic pressure building up there, we can see water moving sideways. Now, I did a training course yesterday and it was all about presenting. And the one thing we were told was that we should only do 3 points. So if Steve's watching this now, his skin is probably crawling because I've got him put 4 points on the slide, but I couldn't really see a way around that one. So there we are. So moving back to the surveying aspects of it. When I last did a webinar, it was following the launch of the joint position statement, the JPS 22, which was a collaboration between ourselves, Historic England, and RICS, which was looking at the investigation and the effects of moisture on traditional buildings. Might not be that exact title, but it was words of those words, but in a different order. But that was the title, and it's a pretty cool document. And one of the things I like about that is it tells us we shouldn't just be considering the structure, but we should be considering the surroundings as well. Now, I'm not saying that that's unique to that document by any means. For those familiar with 8102, and we will get to that in more detail later, that's been a premise that's been sat in there for 30 odd years. But what I think, you know, there's the pattern there is don't just think of the structure, think of the surroundings, think of the context as well. Think of things like topography. If you're sat at the top of the hill, actually there's some merit, there's some advantage to that. If you're sat at the bottom of the hill, much like we saw in the floods in London a couple of years ago, there's the risk of water sort of percolating down and sort of coming well, doing what water does and going to the lowest point and ends up in basements, unfortunately, or rushing down the hill and finding you. Ground conditions as well. How permeable is the site? If it's a free draining site, then that can be advantageous because the water would drain away quite quickly. If it's not a permeable site, what that's going to do is mean you're going to have water that's held in the soil. It's going to be held against the structure. As soon as water comes to bear against the structure, then that increases the risk that water is going to penetrate into that building or into that basement. You should also be checking for things like geographical features as well. Rivers, you know, a fairly obvious one. If you find a river if you've got a basement that's next to a river, not only have you got the risk of the high water tables or close proximity of water tables, but you've also got the risk of flooding as well. Then you've got water tables anyway, should always be a consideration. I know that's going to be difficult if you're there on a survey. So they're the things. Don't just think of the structure, think about beyond the structure as well. So moving on to structure. Once you've looked at the surroundings, the context, then go to the structure. And first things first, I'm sure we all know someone that's done it, and I'm sure there's probably a few of us that have done it as well, and probably a few that aren't. Well, let's see if anyone's brave enough to admit it in the comments. Don't miss the basement. Look for clues if there is something that might indicate that there is a below ground structure. You know, it may be converted, it may not. But look for your clues, look for your light wells, look for your windows, pavement lights, all of that. Don't miss a basement. And once you've established there is one, establish, you know, what's the extent of it? How high is how many retaining walls are there? Is it just a partial basement on one side? Is it fully retaining? If it's fully retaining, is it sort of up to a metre? Is it up to full height? So check the extent of it. But then check, is there any areas that extend beyond the scope of the original structure? So is there any decks areas, any bolted areas, is there podium decks? They are areas that are notoriously difficult to waterproof and often prone to water ingress, but you should be checking for those as well. Other things to check for while you're doing your external checks, check for party walls. Again, it seems obvious, but check where your abutting properties are. If you've got dampness coming on through a party wall, is it originating from next door? Is it the source of water? But equally, when you're out there, check roof lines as well. Check if the property is set at the same level. If the roof line goes up, is next door set slightly higher? Is there the risk that even if you're in the basement, that wall is a retaining wall on the party wall, and there's the threat of water or the possibility of water ingress there as well. Other things to do, and often in my mind get neglected and often not thought about, are things like water mains and drains. If water mains near the property and that bursts, you know, that's a huge volume of water to have to contend with. But drains are probably sort of more consistent. We've already established that most of our basements are in our historic building stock. So you don't want to necessarily be relying, not full-heartedly anyway, on drains that are over 100 years old, because you may end up with something like we've got in this picture here, where you've got, you know, a drain that's not flowing very well. They need to be maintained, they need to be looked after, because all you're doing in a scenario like this is you've got water that is, you know, being held against the structure, and excessive amounts of water as well, and all that's going to do is result in lateral penetration of water into the basement. Other things to check, and you know, this is your bread and butter, and you know, probably teaching Granny to suck eggs somewhat here. Construction. Check the age, the type. The age might give you some indication of what the likely waterproofing systems are. The type, the construction. You know, if you've got masonry, that tends to be a bit more porous than if you've got something that's a concrete structure as well. So check that. That's all useful information to note as well. Check light wells. Again, fairly obvious, we've already touched it on with the London floods a couple of years ago. But the last thing you want is, if you've got light wells, if they're not well maintained, if there's drainage in them, you need to make sure that they're actually working, that they aren't clogged, they're not clogged like they are in this photo, that they have the ability to discharge water. So, internal structure. So this is very much aimed at those that are sort of doing the pre-acquisition survey, that sort of thing. If you're down in a basement, and particularly a habitable basement, and you're looking for signs that all isn't quite right, what sort of things are you looking for? I mean, it's stating in the office, flaking paints, that sort of thing, salt, staining, all of those would be a good indicator that there has been water ingress at some point. And the thing, of course, to bear in mind, just because it's not wet at that time doesn't mean there isn't a history of water ingress, and there may be some telltale signs that that's happened. Check the finishes as well, another important thing to bear in mind. So if you've got exposed brick, you know, is there the presence of a waterproofing system? If you've got plasterboard, you know, is it just a lining system? Or is there actually waterproofing behind? It's not unheard of people just sticking a load of plasterboard in a basement and then hoping, you know, it's just cheap bodge. But you know, unfortunately, and I will get it into a bit more detail with basement waterproofing. Unfortunately, if you don't get the good contractors and people understand what they're doing, there can be a lot of corners cut, and that doesn't necessarily always end well. So check for, you know, if there's plasterboard, you know that if there are render finishes, that in itself could be part of the waterproofing system as well. So that's worth bearing in mind as well. Now, with any structure, as far as waterproofing goes, there is always one place which is the inherent weakness, which is the wall floor junction. You typically have two types of construction where they meet each other. So if you are doing an inspection of a basement, you always want to try and walk around the perimeter of that basement, because if there was ever going to be any evidence of water ingress, the chances are that's where they would be. So always try and have a look around at the perimeter of that building, because where you have those two construction elements meeting, there's that inherent weak point, and you can get water ingress. Check the construction types as well, notably the floor slab on there as well. You've got a flagstone floor, if you've got, which is fairly typical in a lot of old basements, but there's not a lot there to resist the passage of water. So if you've got a flagstone floor, you might need to be a little cynical about what provision for ensuring water is kept out is there. Has the floor been replaced? Is there a new slab there? If there's a new slab, is there some form of waterproofing in there? All things that you should be sort of keeping an eye out for and checking as well. So going back to our heritage, as it were, for the Property Care Association anyway, embedded timbers in wet environments are always at risk of timber decay. So if you are there, you want to be checking for the risk of embedded or the presence of any embedded timbers. The most obvious ones, of course, are going to be your floor joists. So if they're, hopefully they're above the DPC. If they're not, then you want to be checking that the moisture content for those. And this is where your electronic moisture meter is going to be invaluable. Moisture meters in basements can be of limited value, and we will get to that in more detail shortly. But when it comes to checking moisture for timbers, that's brilliant. That's what they're there for. So make sure if you've got timbers, make sure particularly built-in timbers, get as close to the built-in section as you can, take moisture content, and establish, is it up 20%? Is it below? Is it at risk? Make sure you're checking. The problem is, of course, if there's a waterproofing system, you may not necessarily know if all the timbers have been removed. You're never going to know that. But it's a consideration you should be thinking about as well, particularly if there's a lining system, that sort of thing. Another area to check as well, staircases. Newel posts on staircases, if they sort of go through the waterproofing system, how are they terminated? Are they into wet soil or into earth? So check the moisture content on staircases as well. They can also be very problematic with regards to waterproofing systems as well. They, particularly with poor workmanship, they might not want to be removed, and they could be embedded in the wet side of any waterproofing. So just bear in mind, always sort of approach staircases with caution or with an air of caution, and sort of just make sure they've all been done properly. Spoken a lot about timbers, but equally bear in mind if you've got any steel elements as well, any structural steel, beware of corrosion, particularly where there's moisture as well. So I've already mentioned waterproofing quite a bit. So the reality is, if it's currently being used for a habitable space, then there is likely to be some form of waterproofing. So if you can find it and it's readily visible, you want to record the type and what sort it is, the existence, ideally, how long it's likely to have been there. But don't just check it internally, check externally as well, check for land drains, the position, are they maintainable? However, the reality is that in most basements, the waterproofing won't be readily visible. You're not going to be able to see it. It's going to be brought up to a reasonable aesthetical standard. People aren't necessarily going to want to have whatever the waterproofing is as their finishes. So you may not know what's going on. And this is where it actually starts to get difficult, because if you're going in there to do an inspection and you can't see where the waterproofing system is, how it's done, how are you actually going to give any reassurance to your client? And that's where you're really at a disadvantage. So the best way, if at all possible, is speak to your client. They might be able to give you, or it will give you sometimes, the easiest way of establishing what the waterproofing is, when it was done, how it was done. But that's not all you should be looking for. Actually having that conversation with your client can give you some really good insight. It can give you an indication as to sort of the history of the property. Has there been any work done? Has there been anything removed? They can tell you whether it's actually failed in the past. Have they had any issues? They can tell you, the history of the work, previous uses. they should be able to tell, or they may, I should say, be able to tell you about any existing guarantees as well. So most waterproofing work done by good contractors will come with a guarantee, typically 10 years. Most contractors or good contractors will be able to offer you an insurance back guarantee on that as well for that extra level of reassurance. Things that if you are in a basement, you should be sure, and you can speak to a client, you should be checking with them. However, not all waterproofers were born equal, unfortunately, and there are a lot of have a go Charlies. I think that's an expression I've just made up, but there's a lot of people that see it as quite a lucrative market. They will have a go. They don't necessarily have the relevant experience or skill and understanding of waterproofing. And if you are there, if you are presented with paperwork, guarantees, anything like that for that works, then check who has done the waterproofing. Check their credentials. Do they look like someone that's had experience? Are they affiliated with a trade association that sort of regularly vets them, such as the PCA, of course, unshameless plug there. Have they got suitable qualifications? You know, can they demonstrate their competence through something like the certificate, the CSSW? All of these can give a surveyor an extra degree of reassurance that that waterproofing system is compliant or is, of a good standard. So, what does good waterproofing look like? So if you're in a basement, what's the standard you're trying to achieve? If you look at the building regs, if you go to approved document C, which is all about contaminants from the ground and moisture, the one thing that tells you to do is essentially refers you to this document here, BS 8102. Now, it's a bit of the cornerstone for the waterproofing industry. And the reason it's the cornerstone for the waterproofing industry is that it has a proven track record of keeping basements dry. And if waterproofing is designed to this standard, you can have a degree of reassurance that it should have been done by someone with at least some knowledge of waterproofing. This is what, if you've got a system was designed probably within the last 30 years, this is the standard that you should be trying to look for them to waterproof to. Now, first introduced in 1990, when it was originally introduced, it was just looking at keeping groundwater out. It was 2009, there was a revision, and then more latterly, last year, March was the last edition, and that tells us now to start considering sort of all water ingress into underground structures. I think given the climate changes that we're undoubtedly going to face, that is the right thing to be doing. But this document gives us guidance on how to keep water out of our underground structures. It considers a design philosophy that should underpin all waterproofing design, and it's sort of a risk assessed approach. So the one thing I'm not going to do, because I don't think it warrants it here, I'm not going to go to great detail about what 8102 is all about. We've covered that in previous webinars, and hopefully Andy can probably put a link to some of the previous webinars in there as well. So I don't think this is the place to run through all the details. I'll go over some of the headlines, but there is considerably more than what I'm going to go through. But the point I want to try and make here is, if you are a surveyor and you're in a basement and you want to sort of provide your clients some guidance, this is the guidance document that you want to sort of ensure that design is, or the waterproofing is designed to ideally. So the document itself, it sets out grades of waterproofing, and then it sets out methods that can be adopted to achieve that level of waterproof or that level of water tightness. So these are the 3-4 grades of waterproofing that it sets out. And you'll see, we're kind of back to the premise of controlling water depending on the use. So can you have a wet basement? Yes, you can, depending on the use. A similar thing, really. But we've got, for habitable spaces, which is kind of what we're talking about today, if it's a habitable space, it's going to be a grade 3. So grade 3, kind of working backwards here, is no water ingress or damp areas is acceptable, so essentially allowed no water ingress, but then it's got to be ventilated, dehumidified or air conditioned appropriate to the use. So that's your habitable space. Then you've got your grade 2, which is typically a car park or lift pit, by example, where you're allowed no seepage. Damp areas are acceptable, but only if they're caused by condensation, essentially. So it's just that degree of internal environment that is changing between 3 and 2. And the 2 grades for 1 are much wetter. They vary slightly, but typically that might be a light well or something like that. So they're the grades. And if you are there and you are presented with a report for waterproofing and it's a habitable area, you want to see something that realistically is going to be waterproof to grade 3. It then sets out standards or types of waterproofing that can be employed to achieve this. Now, these are broad categories and there are individual products. I'm not going to go into much detail on all of those, but they kind of all 3 work on sort of different principles. Type A is a barrier. So you've got a means of preventing water ingress into structure. So it acts as a membrane or something that actually physically blocks water going in. They can be applied internally, they can be applied externally. Historically, you could have seen them applied sort of within the structure itself, sort of sandwiched, but because of lack of repairability on that, that's not always desirable, so that's kind of shied away from that nowadays. Type B is where the structure itself provides the resistance to the ingress of water. So that is essentially waterproof concrete designed to certain grades. It could be that it's sheet piles as well, clutch welded, but typically it's going to be waterproof concrete. Now, type C is a drained cavity. So this is more of a management system. You're accepting that you may get some ingress of water, but then you're providing provision to deal with that water. So the water will come in and then it will be managed through sort of a series of drainage channels. You've got to create a void to allow water in. You'll deal with it, so you've got a habitable space which is dry, but you're sort of dealing with it internally. Now, depending on the level of risk, you might have used 2 or more of these types of systems, but they're the 3 systems that are broadly out there. So, utilities and penetrations. I'm keen to mention these because if you are doing a survey, these are essentially the bane of all waterproofing systems. So if you're there, you'll note, unfortunately, basements do make a pretty handy location to hide, you know, gas meters, electric meters, any of these things. So the problem is if they're put in, particularly after the waterproofing, or even if they're not moved during the waterproofing, you have areas of potential weakness. If you've got waterproofing, it needs to be continuous. If there aren't and there's discontinuities, then there's the area for potential water ingress as well and failures. You may see that around penetrations such as light wells and things like that as well. We obviously mentioned that sort of fairly early on as well. So check the detailing. If you've got returns around windows, things like that, they might often be neglected or forgotten about. So make sure you check those. Check for continuity with walls and floors. But on, you know, light well, windows, these sort of things, it's not really our area of expertise, but I think it's probably worth of note. There was an incident up in Leeds not so long ago where unfortunately there was a fatality due to a fire in a basement which didn't meet building regs, but some of the escape routes were compromised. So, you know, it's always worth being vigilant on that. So waterproofing. We've already established that most basements are pre-1919. So not all waterproofing is going to look like that stuff that we've just seen. And there could be basements that predate 1990 that are doing their job sufficiently well and well before the guidance that we've just been talking about. So I promised you something a little bit novel and a little bit different, and we're going to go into that now, so hopefully it'll be something that'll be a bit interesting for you, and some of sort of the early forms of waterproofing that you might encounter. Now, anyone knows me, I love to delve into an archive, and that's exactly what we've done here. But this is from an English heritage book, and it essentially tells us that what they've recommended for historic basements was essentially a lime wash, lime plaster and hydrolytic additives. And then if it got bad enough, you just wipe it down, start again, or remove and go through that. Now, I kind of can buy into that, but I kind of can't at the same time. I think tolerance will be fine in some spaces. I'm not personally convinced that that's an approach they would have adopted for habitable spaces. As far as sort of some of the earliest forms of waterproofing in this country goes, that the English Heritage books sort of allude to evidence of waterproofing, pitch and resins and waxes being used as early as 1319. One of the earliest examples was the Old Palace of Westminster, which you've got on the right hand side of your screen there, where they were putting pitch onto the foundations to try and prevent ingress from the Thames. So one of the earliest examples, obviously not in existence anymore. But more recently, so there were evidence of waterproofing products being used as far back as sort of medieval times. Now, more recently, so this come from Jervis, who many of you may know, quite an interesting book, The Englishman's House. It's from 1874. And it's about Queensgate Lodge in Hyde Park, and it's a small little structure, but it's got a basement to it. And it tells us they kept this basement dry. The basement is buried, but as the small structure stood upon a mound and was protected by a dry area, this was of little consequence. So what they're saying here is essentially, because land wasn't so scarce back then, there wasn't such a premium, they could be more picky about where they wanted to build a basement. So if they thought it was going to be a risk, they wouldn't build it there. If they thought that, it was going to be dry, they could take that advantage. It also explains that they'll be using topography to their advantage as well. Stick it on top of the hill and it's going to be less risky. But it also talks about these dry areas. So what are these dry areas? So you can see this is the structure and you've got two habitable rooms quite clearly. What they've decided to do is move the retaining walls away from the structure. See if I can use a big pen. So you've got your retaining walls here and here. And what they've done is essentially you've got a dry habitable wall on the structure, move the retaining wall away, solved your problem. There are your dry areas. So that's from 1874. And it is an approach that got continued. So 1907. This is from another book, and thanks to my colleague Ross for sending these across. So this is 1907, and you've got similar things where they are using this sort of dry area to keep properties dry. So on the side, you can see it's essentially an early form of cavity construction, cavity drainage construction. So there you've got dry area, water comes in and discharge away. Similar thing in the middle, and on the right you've got an early type A barrier protection. I realise I'm running out of time, so I'm going to route through a little bit quicker. Cementitious renders, another thing. So Sika is one of the big brands, so I probably shouldn't name drop, but they are one of the more popular brands out there for cementitious renders. Essentially founded in 1920, as far as the UK goes, become popular because they could be used internally. So they could be used retrospectively on basements. So hugely popular, could resist huge heads of water. So cementitious systems was something that became popular. Just to spread some love, another one that could be used, or you may come across in an existing basement, is a Newtonite lath. So this is essentially another form of waterproof barrier. You tend to see, I've seen it quite a few times in basements, but it will give you, it's a more or less a membrane. It hits it, and you've got a dry inner surface. So typically from sort of post-war period properties, you may see something like that in there. However, I already sort of said moisture meters will be of limited value in a basement. So to expand on that, the value of moisture meters could probably be debated all day. They do have some value and they are very good at what they do. But what you need to be very careful of is the limitations of what they can do in a basement. Now, if you look at those systems that we've just looked at, where you've got sort of a render or a membrane or something, if you're using a moisture meter on a scan facility, behind that, the problem is where that barrier is, behind that is always going to be wet by definition. So if you're using a moisture meter on a scan facility, you're going to get wet readings all the way up the wall. It doesn't mean there's a problem. All it means is you've picked up that the barrier is doing its job because it's holding back some water. If there's no visual evidence of a problem, then actually that's doing its job very, very well. So be careful with your surveying equipment when you're in a basement. The other thing to bear in mind, think you can get around it using your pin modes. Be careful as well, because if you've got, if you're going to stick pins into a basement wall, or drill and try and use your deep probes, whatever you want to do, you're going to run a risk of compromising the waterproofing system, and that's the last thing you want to do, because the last thing you want is a pinprick for a waterproofing system that's holding back a body of water, because the last thing you're just going to see is spare water coming through. So be careful not to damage any waterproofing system. So what does that mean? Be careful using your moisture meter below ground. There are some other surveying equipment that you can see in that picture which will be of more value as well. And the same with anything, it's just got to be a tool in your arsenal, a moisture meter. So you need to have an understanding of the environmental conditions as well. So to be able to distinguish between condensation and water ingress, and we'll get onto condensation in a very, very short while, so I'm going to have to rattle through. So another really popular form of waterproofing in modern structures, or popular since sort of the mid-80s, is cavity drainage membrane. So the plastic form has been around since the 1980s, which essentially you're allowing water through, you're going to hit a membrane, it's going to drain down, and then it's sort of seen off by drainage channels. Some of the early versions didn't necessarily have the same provision of drainage or drainage channels, so just bear that in mind as well. But drainage channels come from about 2000. Now, the problem with this, obviously, water comes in, it's dealt with by a pump or gravity drained. You've got to ensure that, particularly if there's pumps, that they are maintained, that they're always working, that they're serviced. These systems are dependent on maintenance. So if you do encounter a cavity drainage system in a basement, you've got to make sure that there is, a sufficient program of maintenance. So what might that look like? Well, ultimately, with drainage channels, you should have points of maintenance, so you can jet through the system to clear any blockage. If you're in a basement, you might be able to find something like this. So this is sort of a quite a discreet one, but it's a drainage cover, a drainage port, where you can flush a waterproofing system. There are various types. Some might look more like a letterbox. Others might simply look like a screw cap sort of thing. But there are various types of sort of maintenance points out there. But if you suspect you've got a Type C system, you should be looking for how that maintenance can be carried out, and look for service schedules as well for pumps and things like that as well. Another novelty for those that are sort of more long in the tooth as far as industry goes, if you've ever seen something like that, another question for you, who's seen that before? This is another sort of predecessor for cavity drainage, where you've got these sort of tiles, tripod type tiles, which has a void underneath to let water sort of run through, and then you've got a bitumen coating on top as well. So obviously in a triangular format, but there you go, there is another predecessor to sort of cavity drainage as we know and love it today. So on the home straight, we're going to look at condensation. I'm sure most of you know what condensation is, but it's essentially liquid going from its vapor form back to its liquid form. And basements tend to have sort of an inherently greater risk of condensation. Typically, they have less air exchange. They won't have the windows, they won't have the infiltration, so you tend to have less air exchange. If you have less air exchange, then you tend to have a greater build-up of moisture, and that can be problematic. Not only that, but basements tend to run a bit cooler as well. So if you've got basements that are running cooler, and perhaps this is a diagram that will illustrate this a bit better. So relative humidity is the amount of moisture vapor in the air expressed as a percentage of the maximum it can hold at a given temperature. Now, the way it works is that the warmer the air, the more moisture it can hold. So if you add air that comes into a cooler basement, then the chances are you're going to increase the relative humidity. So if you can imagine in those scenarios there, you've got the same volume of water, but because the temperature decreases, you can't hold as much water, you reach the capacity that air can hold, and then you're going to have condensation occur. So be mindful that you may get condensation in basements as a result of that. What's the visual evidence for condensation in basements? Well, it's the same as you get above ground. You're going to get your run marks, but that can be deceiving as well, because if you're getting run marks, is it a failure of the waterproofing? Is it down to condensation? And that is where it's essential that you can establish what's going on with the environmental conditions, because again, you don't want to do anything that's going to compromise the waterproofing system. So you should be going in with a hygrometer, surface thermometers. Can you check, is dew point occurring? And the other thing to bear in mind, on that note, is typically above ground we have a condensation season, because we have a basement, we need a temperature differential between inside and outside to have the air cool sufficiently to cause condensation. So for that reason, above ground we have a condensation season, typically of October to April, something like that. The colder months is when we have condensation. It's not that cut and dry with basements, because with basements, because of thermal mass of a wall, they tend to run a bit cooler. What you can have, particularly in the summer, you can have an ingress of really warm, humid air going to a basement, but because you've got a cool wall, because of thermal mass, etc., you can have condensation occur within a basement in the summer. So be mindful of that, because that's also going to give you a reading in the middle of summer, and you may instantly go to look to discount condensation, but it could be occurring. So be mindful of that. And that's another reason why moisture meters can be of limited value when doing surveys on a basement. And you may be looking more to your visual signs of your defects and your expertise and knowledge. And again, if in doubt, go to a specialist. So if it's a habitable space, it needs to be ventilated. We've established that when we looked at 8102 and our 3 grades. So it needs to be ventilated appropriate to use. What's going to be appropriate to use? Well, if it's a habitable space, it's going to be appropriate to building regs, which is approved document F. So if it's a ventilated to approved document F, it should be commissioned, and really it's got to be maintained as well. So is there a record that it has been commissioned? Is there fans there for a start? Other things to check, is it a separate entity to the rest of the structure? So do you have an open staircase, or is there a stairwell to it, or a stairs coming down? If there's a stairs coming down, then you're going to need to treat, if there's a door, then you're going to need to treat it as a separate entity. And there's special considerations for that as well, where you might need to carry on as a bedroom as well. So bear that in mind. So 2 more slides, Andy, you'll be pleased to know, before we can get on to questions 3, sorry, apologise. One last thing on vapor control, just to sort of dispel a few myths. So forgive me, probably going to read it a bit here, but where water tables are low, it can be shown that for grades 1, 2 and 3, the internal vapor pressure is usually higher than the vapor pressure in the ground. With vapor pressure, what happens is high pressure moves to low pressure, much like a weather system. You can think it sort of tries to reach equilibrium, is what I'm trying to say. So what you tend to get, if you've got low water table outside, but you're getting moisture production from your internal environment, you tend to get vapor drive going from inside outside. You don't tend to get it coming in. If you've got high water tables, then water vapor will penetrate, but at such a low rate that it's normally of no significance. So, for example, if you've got a type B concrete basement, which is 10 metres by 10 metres by 3, 300 mil thick, under a 10 metre head of water at 15 degrees internal temperature, vapor will penetrate, but it will be at such a slow rate that in 24 hours it will only increase the relative humidity by 1.5%. And that is in a totally unventilated area. And we know that it's, nowhere is completely unventilated. There should be a provision of ventilation, and if it complies with the building regs, there should be several air exchanges an hour. So in reality, it doesn't make that much difference. So to wrap up, basements can be tricky to survey. They can be tricky because you may not have access to much like that room there. You've no idea what the provision for waterproofing is. There may be some subtle signs, and that is, you know, on for a surveyor to either identify them or suggest they go to someone that can. Understand, you know, is the design compliant with 8102, particularly if it's been done, you know, in recent years. Other things, know the limitations of your equipment as well. We've already established moisture meters are of limited value, or can be of limited value, so just be careful. If you're using them, use them, you know, with a degree of skepticism that you might not necessarily get a reading because of a failure or anything like that. Everything could be fine, or it's, you know, it could lead you down the wrong path. So you shouldn't use it in isolation, but use it with, you know, additional knowledge and other equipment as well. And Andy, you'll be pleased to know, I think I'm a few minutes over, but there we are.
Well, here, James, many thanks for sharing those insights. I think on behalf of everyone, I think it's I just want to say thank you for sharing your knowledge there. That was another great presentation. I do have a quick question though, just before we go into questions. You mentioned at some point halfway through the webinar about don't miss the basement clues, that there's a below ground structure. That really surprised me, because I actually thought in this day and age when property values are so high that basement spaces were a very desirable space if you've actually got it. I mean, why would someone hide a basement? Is it because they just simply are completely unaware of it?
Not everyone wants them, do they? They're damp. Getting it done properly is not cheap as well. And some people, you know, there's a lot of terrace places that just simply don't use them. It's not, you know, if you can afford to have it done, it's a nice luxury. If, you know, some people might just want to use it for storage. There's not. It's up to you, and it's personal taste. There's no hard and fast rule that says if you've got a basement, you must use it. You know, and particularly in the past, they went out of fashion because they, you know, were damp and not particularly well ventilated, and might have been seen as a burden. So,
well, fair enough. Well, folks, just to let you know, I don't have a lot of questions in, so if you do have a question, now is the time to kind of fire it across. You can either fire it across on email at andy@property-care.org, or just stick it into the chat and I will pick up on it. So, James, I'm going to start off with a question that came in from Jenny Cole via email, who advises she's a chartered surveyor. She's asking, do building regulations require more than one kind stroke level of waterproofing system? And a second part to it, she's also asking, out with asking the occupant, are there any tips you can provide to help a property surveyor identify waterproofing systems added? It's a 2-point question here. One about the building regs and the requirement level, and 2 about key tips.
Okay, right. Building regs, as I've already alluded to, just refer you to 8102. 8102 says you should assess risk. Depending on the level of risk is then when you decide waterproofing. The warranty providers might assess that their deem or may consider their level of risk, and they will make their decisions, and that may affect things as well. But as far as do the building regs say, the answer was no, it doesn't say you have to use 2. The building regs simply say go to 8102.
Fair enough. Well, moving on.
But what's the second part? Sorry,
the second part was, you know, if out with asking the occupant, are there any key tips you can provide a property surveyor in order to help identify the different waterproofing systems?
Yeah, okay. So it's difficult, as already alluded to. So if it's a concrete structure, if it's a type B, you're really going to struggle. It might be a more modern structure, you know, so you might be able to identify that, but the reality is that's going to be difficult from a visual point of view. If it's a type C, one of the big giveaways will be that there should be some form of maintenance provision. Well, there's likely to be either a point where it comes out, so if it's drained, gravity drained, but there should be a sump and pump as well. If there's a sump and pump, the occupant will know where they are, but you know, you might be able to find one of those anyway. But look for maintenance points, look for that. Your chances are not necessarily always, but the likelihood is it might be a plasterboard finish as well. So that might give you a clue that there might be a waterproofing system behind that as well. What other indicators might there be? I mean, other than that, I mean, check the floor finishes as well, but that might not necessarily always give it away. If you've got a floating floor, a floating wooden floor, that might be an indicator that there's a membrane underneath, but that's not hard and fast. Yeah, and type A's, if there's a render, you know, that it could be a cementitious render itself, that could be the waterproofing system. It might not be, there could be something hidden behind, but again, it's difficult. But you know, you're going to struggle to find anything externally anyway. And this is the whole point of the webinar, to be honest, is there are some tips, but it's not easy. And you know, particularly if you're not a specialist in the field, then you might struggle, and you know, you might need to do some exposure if you really want to get to crux of it, but you know, it's not always easy.
No, I hear you. Well, moving on, next question comes from a Simon Miller. I suspect Simon's a chartered surveyor as well, just from the way he's kind of framed the question, but cutting it down, he's asking, well, looking at and surveying a basement, along with evaluating for dampness, should we be considering radon as standard?
Sorry, what's the question?
He's basically asking, well, he's in a basement and surveying a basement, along with looking at dampness, should he be considering radon on every basement?
Okay, yeah, I mean, it's always a risk. It depends what you're there and doing a survey for, though, doesn't it, really? We're not talking about base conversions, we're you know, talking about pre-purchase or you know, the surveying for an existing defect. But yeah, it probably shouldn't be too far from your mind anyway, and you probably are going to be doing that as part of your overall checks anyway. Fair
enough. Okay, well, moving on. Next question comes from an Adrian Locke. He's asking.
Well, that's actually John Spearman's made a good point. Yeah, checking in cupboards is actually a good shout for membrane. So meter cupboards, that sort of stuff. I sort of alluded to how problematic they are, and you know, there tends to be an opportunity to miss them or save money by not moving them or whatever. Sometimes they are done, but you know, they might not need the same finishes in there. And in there, you may get evidence of membrane systems or, you know, other systems. So yeah, good shout, John.
There we go. Thanks, John. Well, moving on, Greg Henley is, and now this is actually potentially a shameless plug, but Greg Henley is actually asking, what would you consider an appropriate level of competency for a surveyor that is reporting on below ground spaces? Now, I think you and I both know the answer to what we would consider that, but I'll let you maybe explain.
You know, a bit of a shameless plug, but I would encourage anyone to do the CSSW. Of course I would. Get an understanding of 8102, the requirements of, even just come and do the course at least. You know, it will, I think, open your eyes quite a lot.
Well, okay, well, moving on. Last question, I think I've only got just one more point just before we kind of sign off. That comes from a Peter Monk, who's asking a question: when consideration is suspected with ventilation, and actually, do you know something? I'm actually struggling to maybe figure out what Peter is asking. Peter, I tell you what, I'm going to take away your question as a point, and I'll maybe get James to kind of answer that afterwards.
Yeah, no, I've got his question. Yes, absolutely is the answer, Peter. If you've got no means of managing moisture load in the property, it's absolutely going to contribute. Of course it is.
Well, perfect. Well, just moving on, folks, because time's a ticking. I just want to point you to that if you are looking for any additional information and guidance, there is a whole host of information available on the PCA website. Starting off with the PCA document library, you'll find a whole variety of codes of practice and best practice documents on there. There are other places, you heard James mention it earlier on about BS 8102. And if it's ventilation related that you're concerned, there is, of course, approved document F. if you are thinking about ventilation and stuff like that as well, I'm just about to allude on to another webinar that's ventilation based in just a second. There is as well a whole library of videos that of useful content that you can go into, and as well a whole professional section. Now, I've just shared the links just on the chat there. I'll have them in the show notes for anyone that's watching the replay of this webinar. If you are interested on learning even more, then there is training courses there available for those that are interested. There is one of our flagship courses for severe training in structural waterproofing. There is, if you've got your operatives as well, technician training for structural waterproofing. But there is, of course, a variety of other structural waterproofing based courses that you can look at. And again, I've just shared that via the chat to anyone that's interested. And again, I'll share that via the show notes. Just before we go, just a reminder to all of our upcoming 2023 International Structural Waterproofing Conference, which is in 3 weeks' time. We have very few tickets available for this conference now. If you are interested in it, then please do jump on to the website, take a wee look. There's a great program. I've just shared the link to it again in the chat, and just don't miss out. Don't miss out on the last remaining tickets. Just before we go, just want to let you know of the next webinar coming up on the 27th of July. It is ventilation based, titled Domestic Ventilation Competency. I can't even say the word competency. Do we need to aim higher? That again, that is on the 27th of July. Hopefully we see many of you there. Last but not least, I just want to say a big thank you to yourself, James, again, for sharing your knowledge and insights. I want to say a big thank you to everyone that joined us this morning. And last but not least, we hope we see you next month, and we hope you have a lovely rest of the day. Goodbye, everyone.